Yeah.
People are still sober, eh?
Yes.
That is very good. That is very good. So members,
No, 10.
Yes.
since our calculators are being programmed to log to base 10, which means the base must be what? The base must be
10.
must be 10. The base must be 10. Now let's see, how do we express logarithm? Because when you look at what I've written here, I said when I write log of b to base a equals to c, a is our base, b is called what? Argument. Then c is called the power or the what?
Exponent.
The exponent. Now, what do we mean by that? Take for example, if I tell you, find for me log of 1,000. Log of one what?
1,000.
Log of 1,000. That's why Napier was very helpful here. Because when I said, like a case I was giving the case for the rectimeter, which we use for measuring the magnitude of what? Of the earthquake. So we cannot keep talking of these large numbers. You know, people don't like talking of large numbers. You just talk of simple terms, okay? So
yes.
Napier came out with a way of expressing this number so that it becomes simple for a human being to understand, for ordinary people, a human being to understand. Because when you talk of 10 to the power 3, no one will understand that. You get that?
Yes.
So if we find a way of expressing these large numbers in power form, and that power we refer to them as what? Logarithms. We refer to them as what? Logarithms.
Log.
Now, we're going to combine the idea of indices, because we said logarithm is another way of expressing numbers in power form, not so?
Yes.
Yes. Now, the question is now we want to find log of what? Log of what? 1,000.
Log of 1,000.
So which means in this case, our argument, what is our argument, members? What is our argument? Our argument is what?
1,000.
What is our base? Our base is what?
10.
10.
What is missing? What is missing?
Exponent.
The power is the one which is missing, not so?
Yes.
Let's see, how are we going to get the power? How are we going to get the power? So we are going to say log to base what? 10 of what? 1,000 is the same as log to base 10. But we know that you come and say, yeah, but 1,000. 1,000 is the same as 10 to the power what? Members, 1,000.
3.
Now I come and put it here. I put 10 to the power what? To the power 3. Now, again, Napier argued. Napier what?
Argued.
He said, now to make this power, because now human being, people will not, ordinary, if you are not a mathematician, you will not understand this. Then he came out with the idea, we shall look at it, he termed it as laws. He termed it as what? Laws. Now, he said, for it to make it easier, I have to bring this power, what? The power is shifted the power to that point. I think that.
Yes.
Now he came out and then we said we can write it as 3 log to base 10 of what? 10. I think that.
Yeah.
And he also said if you have a number with the same base, the number with the same what? With the same base, that number is it? Yes.
Why do we shift you?
That's argument is brought by Napier. That's why John. That's why I'm using his name. I'm not using my name. Okay. Are you together, members?
Yes.
Yes. I'm explaining to you concept brought by who? By John Napier. Okay.
Yes.
Yes. So for him, he said to make it easier, this power must be shifted from where up to where? To here. That's why now we write it as 3 log to base 10. Log, I think that.
Yes.
Then he also added that if I have number with the same base, if I have an argument with the same base, that number must be 1. That number must be what? 1. He also said also log to base 10 over 10 must be equals to what? Members, have you seen that?
Yes.
That's why now I can write log to base 10 of 1,000 as 3 times what? Now because log to base 10 over 10, we said log to base 10 is what? is 1. So which means I can write 1000 log to base 10 of 1000 is equals to 3 times what?
1.
Which will give us log of 1000 is equals to what? 3. Now, and that one now makes sense to what I was giving you here. When I said log to base A of B is equals to C. So which means, you see, I think the power, we said C is the what?
The power.
C is the power, not so. And you see, 10 is to the power what? Our power was what? Our power was?
3.
Our 3. That's why our answer is 3. Have you seen that? Have you seen that?
Yes. Yes.
Now, let me give another example. Let me give another example. Let me say, I want to find log to base 10 of 10,000. Of 10 what? We know that 10,000 is the same as what? Now looking, now you pay attention here. 10,000 is the same as?
10 to the power 4.
But 10,000 is the same as 10 to the power what?
4.
10 to the power 4. Which means, members, if we look at it in this simple way, what is log? Which means log of 10,000 to base 10 is what? The answer must be what? The answer must be?
4.
The answer must be 4. But how do we arrive to 4? How do we arrive to what? 4. To 4. So we shall say log of to base 10. We say 10,000 is the same as 10 to the power what?
4.
To power 4. Which can be written as 4 log to base 10 of what?
10.
And we said, but log to base 10 of 10 is what?
1.
Is 1. So log to base 10 of 10,000 is going to be now what? 4 times what?
1.
Which the answer is what? The answer is what?
4.
Now look, have you seen now?
Teacher,
You have seen, eh?
I've not understood the part.
Yes?
This part where it says, but log. Teacher,
Yes, please talk. Be audible enough, please.
I've not said log to the
Yes?
log 10 to log.
Yes? No, looking, I'm not getting you. I'm not
I have
getting
not
you.
understood that
I'm not getting you, please.
log.
Your network, your
Terrible.
network is not okay. Your network. Members, are we together?
Yes.
Good. So members, which means if they asked you, find for me log to base 10 of 100, what do you get? The answer must be?
2.
The answer must be what?
2.
2. Now, let's prove it with our calculators. Let's prove with our calculators, okay? You press log. I see how you're going to do. You press what?
Log.
Now, what do we want? We want to find log of 100. You press log of 100. I think that. Answer.
Yes.
I think that.
Yes.
The answer is 2. Log of 10,000. Log of 10,000. What's the answer? The answer is what?
4.
4. Log of 10,000. I mean of 1,000. The answer is it?
3.
3. As simple as what?
That.
As simple as that. That's what logarithm is all about. Expressing numbers in power form. Are you together, members? Yes. Now,
Teacher,
yes.
so it means that it only works out for numbers that have only zeros.
Yes. But not only, but we shall see how we can express for other numbers. We are going to see as we proceed, we are going to see how we can express logarithm of other numbers. Okay?
Yes.
Yes. But this one, I'm just laying foundation. I'm laying what?
Foundation.
so that we understand what logarithm is all about. So far, so good, right?
Yes.
Good, 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 good. Mm-hmm. Members,
Yes.
what we have seen here, the first one, what we have seen is when we have logarithm powers of 10. Powers of what? Powers of 10. Now let's go and see logarithm of numbers. Let's go. Subheading logarithms. Logarithms of numbers. Logarithm of numbers between 1 and what? 1 and 10. Like the question someone was asking, how do you get for other numbers? How do you get logarithm of other what? Of other numbers. Logarithm of other numbers. Logarithm of other numbers. See? Members, are you getting me?
Yes.
We, say we write. We suppose a to the power 0 is equals to what? A to the power 0 is equals to 1. Then 10 to the power 0 is also equals to what? 1. Okay? Members, are we together? Suppose a to the power 0 is equals to 1, and then 10 to the power 0 is also equals to what? 1. That's what we have seen from indices. That's what we have seen from